All right, let's dive right into one of the biggest challenges in all of cybersecurity. How do you actually communicate securely when you know for a fact that someone could be listening in? The answer seems pretty simple at first, but as we're about to see, it hides a massive, almost world-breaking problem.
So think about it for a second. If you have a physical lock, what's its weakest part? Is it the steel? The complex tumblers inside? Nope. The weakest part of any lock isn't the lock at all. It's the key. And specifically, it's how you get that key to the person who needs it. This one single idea is the foundation for everything we're about to uncover.
For literally centuries, the most straightforward way to communicate in secret was with something called a shared secret. It's an idea that's just as intuitive as it is powerful, especially when you're only dealing with two people.
Now, this method has a more formal name, Symmetric Encryption. And symmetric just means the same on both sides. You use one secret key to scramble or encrypt your message, and the person on the other end uses that exact same key to unscramble it. One key to lock, and that same key to unlock. Simple, right?
And this really just boils it all down, doesn't it? As long as you and I are the only two people on Earth with a copy of the key, our conversation is totally secure. The secret we share is the key. The easiest way to picture this is with a real-world lockbox. Imagine I write a message, I put it in the box, and I snap it shut with a padlock. Then I send you the box. Since you have an identical copy of my key, you can open it right up. Anyone else who gets their hands on it? Well, to them, it's just a locked box.
Okay, so it sounds perfect, but here's where this beautifully simple system develops a catastrophic crack. The weak point, like we said right at the beginning, isn't the lock or the encryption, it's the handoff.
This is the million-dollar question, isn't it? Before you can ever send a single secure message, you first have to somehow get the key itself to the other person. And that initial transfer, it has to happen over an insecure channel. You have to text it or mail it or hand it off. And that is your moment of maximum risk.
So let's introduce our villain for this story. We'll call her Eve, the eavesdropper. Eve's job is simple. She just sits on the communication line, the Wi-Fi signal, the internet cable, and she can listen to and copy everything that goes back and forth between you and your friend. So let's watch how this attack plays out step by step. Alice creates a secret key. Great. Then she sends that key over to Bob. But remember Eve? She's listening. As that key travels from Alice to Bob, Eve just quietly makes a copy for herself. And just like that, it's game over. Now Alice, Bob, and Eve all have the key. Every single message that Alice and Bob think is private, Eve can now read as easily as they can. Their secure channel was compromised before they even sent the first message.
Now you might be thinking, okay, I get it. I just have to be really careful with that one key handoff. But what happens when you're not just talking to one person? What happens when you have a whole network of people? This is where the problem goes from being a little risky to completely impossible.
Let's watch how fast this gets out of hand. If it's just Alice and Bob, they need one shared key. Easy. But now let's add a third person, Carol. Suddenly, Alice needs a unique key for Bob and a second unique key for Carol. And if Bob and Carol want to talk privately, well, they need their own key too. That's a third key. We added just one person, and we've already tripled the number of keys.
And this is where it gets, well, kind of insane. Take a look at how quickly this spirals. With just 10 people in a group chat, you suddenly need 45 different keys. For a small company of 50 people, you're looking at 1,225 keys. And remember, every single one of those has to be created and handed off securely, without Eve seeing a single one.
Now, there's a formula for this, but you don't need to memorize the math. All you need to know is that this number doesn't grow in a straight line. It's not a gentle slope. It explodes. The growth is exponential, and that makes managing it a total nightmare.
And here it is. For a relatively small network of just 100 people, you would need to securely create, distribute, and manage nearly 5,000 unique secret keys. It's not just hard, it is, for all practical purposes, impossible.
And the reason this key management nightmare is such a deal breaker is because of a fundamental rule in security. A rule that puts all the pressure, 100% of it, directly on keeping that key secret. This is known as Kirchhoff's principle, and it's absolutely crucial. What it says is you have to assume your enemy, Eve, knows exactly how your encryption system works. She has the blueprints. The only thing she doesn't have is the key. The entire strength of your security has to rest on that one single thing. And as we just saw, keeping thousands of keys secret is a losing game.
So let's just pull this all together. We started with this really simple, really elegant solution for two people to talk privately. But when we try to apply it to the real world, to our massively interconnected lives, it just completely falls apart.
So, let's recap the core failure. Symmetric encryption just doesn't work for the modern internet. Why? First, every single pair of people needs their own unique key. Second, that moment you try to send the key is your weakest point. It's when you're most vulnerable. And finally, as soon as you add more than a few people, the number of keys you need to handle becomes mathematically absurd. This, in a nutshell, is the key distribution problem. Which leaves us with this incredible, almost paradoxical question. If sending the secret is the problem, then how in the world do you set up a secure channel with someone without ever actually sending them the secret in the first place? How do you share a secret without sharing it? Think about that one, and we'll see you next time.